All right, hello again, kiddos. We're going to go over the practice problems at the end of your periodic trends introduction practice notes. So the very first question asks us to put in order some elements by ionization energies. And before we do this, I want to remind you what that trend is for ionization energy. So remember that ionization energy is going to, and I'm going to use IE to abbreviate ionization energy. It's going to increase going up a group and it's also going to increase going left to right across a period. All right, so now we can tackle that first practice problem. All right, so the first practice problem asks us to put bromide, arsenic, gallium, calcium, potassium, and krypton in order from highest ionization energy to lowest ionization energy. So we are going to set up a spectrum here. So we're going to put high ionization energy on the left, and then we're going to put low ionization energy over here on the other extreme. All right, so I want to use a highlighter to show you what element we're talking about. So we are looking for bromide. We're looking at gallium. We are looking at calcium, potassium, krypton, and am I missing one? Arsenic. All right, so you'll notice that all of these are on the same period, which should simplify things a little bit. Okay, so if we look at the trend, we can sort of just place these going lowest to highest. The potassium is going to go over here. Calcium is not as low as potassium, so it's going to go just to the left of it. And then gallium, arsenic, bromide, and krypton right at the end. All right, do not confuse yourself. Krypton has an ionization energy. We can rip off that electron, but because krypton over here, let me draw like a little arrow, is a noble gas, it's going to take a huge amount of energy to rip off that electron, right? So the ionization energy for krypton is huge, therefore it is the highest. All right, so before we go on, I want to erase these highlightings because we are going to see another group of elements. All right, in question number 2, we're looking at atomic radius. Right? Now, atomic radius is the exact opposite from ionization energy. All right, so we're going to use a different color. The atomic radius is going to increase It's going to increase going right to left, and it's also going to increase going down a group. Very good. So number 2 gives us the following elements. This time we're looking at polonium, we're looking at tellurium, we're looking at selenium, sulfur, and oxygen, right? So most of the elements in group number 16. And again, we are going to set the high atomic radius on this side and the low end over here, where AR stands for atomic radius. All right, so polonium is going to be the element with the biggest atomic radius. And it's going to, the atomic radius is going to decrease going up. It's going to be followed by tellurium, selenium, sulfur, and finally oxygen. All right, we're going to switch pen colors again. And erase these. And look at number 3. All right, number 3 is a little bit different. Here we have 3 new elements. They've been made up, and we are just given their electronegativities. So if we're looking at electronegativities, this periodic trend basically follows ionization energy, with one very important exception. Noble gases, right, all the elements in group number 18 do not have an electronegativity, right? They are unreactive. So what we see is for the entire group number 18, the elements have an electronegativity equal to 0. Everything else remains the same. The electronegativity, like the ionization energy, is going to increase going from left to right, and the electronegativity, much like the ionization energy, is going to increase going up a group. So if we have jaltene, with an electronegativity of 0.9, erludon, our other made-up element, with an electronegativity of 3.3, and motinium, with an electronegativity of 2.7. Well, what that means is that jaltene is going to be further to the left, followed by motinium, And lastly, Erludon will be closest to the right, but not in the noble gases.